Okay, I am back again in the stream. Not sure if it considers this as only one stream or if there will be two streams, but at least I am back. So the LCD is working also again. So git checkout, so we undo our change. Make, there's no make, there's a make file. Ah, the make file is in make. Make, does it work this way? Yes. Makes everything. I'll show you just so you once, and afterwards I'll only do it on myself on the side. Make flash. Does it detect it? Clock speed. I think I have to switch on. Yes, the scope with the battery, so it detects the device. Yes. So here. Oh, okay. I have no idea why it now works. Was it really just an issue with the glue? Or there was a wrong contact? I mean, I looked at. I don't download the source code. They change it because I haven't, because it doesn't work. Because it works just for fun. Although I do it from time to time, but seriously, now it's working perfectly fine with the original. I have no idea what's happening here. Just cleaning the contacts, make the right connection. That might be the case, though. There might be some wrong connection on these things. And cleaning it could have solved it. That's fast debugging. I really expected I had to look at the signal trace, look at what speed this, if the clock was correct, if the data transmission was correct, the slew rate was correct, and so on. But now it works just by cleaning contacts. That's awesome. Let's try if it does work. Let's switch back to the other screen so you have a better view, because this seems to work. Bench. Oh, it's I'm a bit deceived, actually. I'm a bit sad or somehow surprised. Normally when you have an issue you want to debug, it takes at least 2 times longer because nothing happens correctly. But here, just cleaning the device made it work. Is it a test signal? I don't know if this has a test signal output. I don't think so. There's also no keypad. Can I make it? Okay. This way you don't see too much of the glare of the headlights that you do. What if I angle the camera? Okay, that looks better. So wait, let's put kind of a signal. I don't have any the touch buttons, but I will just put any kind of signal. For that I will use my oscilloscope, and on the oscilloscope there is I don't have any bench power. Let me switch on the power on the bench. Camera still works, that's good. Camera is on the bench. Up, oscilloscope is starting, and the oscilloscope normally I think it's 1 kilohertz output on the probe. This is ground. This. Okay, the signal is not seeable. Curiously, as a connected ground, so this is a 1 time 10 times probe. We are on 10 times. Let's put it on 1 time. There is a bit of activity. I don't know why. it is connected through, wait, let me show you the issue. As soon as I connected this thing to ground, the signal went low. I don't know why it went low, because it should reference to ground of the oscilloscope. But here we have another ground which is connected, so this already pulls it to ground. If I disconnect it, yes, it's not the same ground. We see we have kind of a signal. It looks really good. Wow. Well, really good. We don't have the correct display, and we will see how it looks like on the oscilloscope, the signal, but for now it's not bad. 200 millivolt, maybe that's why. Let's switch it off. Let's put actually glue back, something on the back to hold it, some tape, and put back the front so I can actually have the touch buttons. So disconnect the USB, and also, yeah, don't use it while you're charging. As I explained for the multimeter, we created the bench multimeter. As soon as you connect it, you have, well, and we saw it, you have connected ground, so there is a reference voltage. It's not floating anymore, and we saw the signal was a bit out of range because it wasn't the same reference ground. So don't use it while you're charging it, except if you have a complete isolation. So let's clean a bit the screen. Let's put some tape. I have tons of different tapes, but I think there is one which I almost never use. This tape, I bought it as kind of an LCD tape, double-sided, but it's very foamy. The double-sided tape is not very sticky, and I almost never use it because I thought it was very sticky for the double-sided, but it's not, so that's kind of a shame, and it's also very thick. But now, for this case, it's really ideal because, let's put it this way, the thickness is exactly what we're looking for. We could also have some foam. I do have some foam, but it's not double-sided. We don't need it to be double-sided, although we do need it to be double-sided because we want this to not flap around in the breeze. Else I would have some other kind of foam, which is maybe a bit better. But let's stick with this one. One side. And no, it's not 3M. It's not 3M thing. Everyone puts 3M because 3M makes the standard and quite good tape. It is the de facto standard. Let's shorten it a bit more. And the tape is not bad, so every Chinese knockoff also put 3M on it, although it is not 3M. Let's put the last one here, so we have kind of, let's put it completely this way. Here. Let's peel the other side of the tape. I hope the foam is high enough. And now, in this case, although I didn't like it before because it was thick, the foam will help it dampen the contact. Up, 1. 2. 3. And luckily I opened the tape. In the beginning I thought I was just, or at least it would be possible to debug just by looking on the signals on the microcontroller side, because the output pin are there, and it's kind of easier to debug this way. But I'm happy that I didn't, and that I removed the LCD, because this really solved the issue. So here we can see my finger all over the screen. Let's get no, this doesn't work. this with alcohol. Let's test if this works. Yes. The microfiber tissue is only to remove the dust. And it's already very dusty. And some of the traces. Screen is clean. Now I can put it back in the case. It's not holding well against the thing, so yeah, the double-sided tape doesn't tape that well, but probably good enough. Let's try it. If not, I will just use other tape, but for now we will do it this way. For the buttons to work well, we have to put the screws back. These self-tapping screws, it's not recommended to really very often put and remove the screw, but we don't have the choice because it damages the plastic. It's meant to be screwed in place once and leave it there. We'll just be very gentle. And you see some bad design case. You see this screw, this and this screw. These are going against the case. So either bad PCB case, or the one who designed the PCB just put a hole, or the one who did the supply bought the screws but the wrong one because it's a bit too large with this annular thing. So what do you expect from this price? For this price? Up. Up. All screws are back. Let's put the battery back in. Battery is in. This case we don't need to close it for now with the screws. So let's try if it works. It does. Wow. And it also looked like this. The original I think he got very inspired by the original software. The original software also looked like this, like you've seen on the AliExpress sites. And we're still having the glare from my headlights. I just need to get the camera from somewhere else, or switch off the lights, but it's getting dark outside slowly. Let's try to switch off the light. Yes, far too dark. So camera, you have even more angle. Up. Up. Come on, keep your angle. What do I screw you for if you don't keep your angle this way? Okay. Now you see a weird angle, but at least you don't see the glare anymore. I have something in my throat. So the screen seems to work. Now let's connect the probe. Let me check on the oscilloscope what the signal looks like. Let's get an oscilloscope probe. Tuck, tuck, tuck. I should show you also. the oscilloscope output, oscilloscope output. Give me a second. Let me connect the probe first. Let's get rid of this. This goes here. This goes here. That's trash. Alcohol goes here. Here. I don't need anymore. Okay. Let me show you the oscilloscope. Oscilloscope capture. Up. Okay, it is capturing. This you don't need anymore. I only need it. Okay, that's the output of the oscilloscope. No, don't need it this large. Okay. So run. No, that is the wrong. This is fine. Up. We are triggering. We should trigger on channel 1. We are on auto. We go to normal. 25 kilohertz. Well, that's what it says. We are triggering on channel 1, yes, but it looks very noisy. It looks very noisy because the ground clip wasn't connected to the signal. Network error. I'm still streaming. Up. Click here to reload player. Let's check if I'm still streaming. Yes, I'm still streaming. And the audio still works? Yep. Okay, so the signal is, do we have 1, 2, it's 1 volt per division, so it's 1 to 3 volts high, and yes, 1 kilohertz, exactly. That's what I thought. So 3 volt, 1 kilohertz. Let's try to have exactly the same thing on the handheld oscilloscope. Whoop. This way. This, come on, oscilloscope probe, hold on. Let's put it on 10 times. Up. Now it is connected. I have, actually it's really useful. So now let's move the trigger point. No, that's not the okay, that's the vertical position we don't want. So mode maybe? No. I've never used, here, 1 time, 10 times. Okay. I'm not sure. Okay, the AC/DC button works, but the 1 time, 10 time does not work. So it only works for 1 time probes. You cannot configure 10 time probes, which is really a shame because 1 time probes distort the signal. 50% button doesn't work. At least this works. So setting the trigger point works, and the trigger works well. That's the vertical position. That's the horizontal position. How do I change the scale? Mode? No. Auto? No. Menu? No. Trigger, single, auto trigger, normal trigger, stop. Single. Okay. I did not figure out how to change the horizontal resolution. Now that's vertical position. That's horizontal position. Auto does not work or does nothing. Stop, okay, does this. Maybe F1, F2. There are two things I would like to change. The horizontal scale and the vertical scale, and none of them I found how to change it. Trigger. Stop. Remove the stop. Someone is calling me. Yeah, let me answer that for you. I'll be back. And we are back online. So the phone call is done. I had to help someone. Now I'm looking at the. Let's change the view. So this is. Let's change the view to. Actually, we can do it this way. Let's look at what is encoded or what the buttons are. Buttons. So the chips we saw, the huge circuit chips on the back. These were not for AC. Sorry, for the ADC or for the resistor divider. These were to actually multiplex or handle all the buttons. So here we have all the buttons. And trigger up, we notice both channel works because stopped work. So we have channel going to P1 and we had down and left working. So we know that all the buttons work. It's not F2 and are connected directly on the pins. Okay. Other hardware attenuation, front end, pin outs. This is well documented. Oh, here are all the pins. This is what the pins I wanted to tap on before cleaning up the device actually and looking at the LCD. Functions, miscellaneous. Button, okay. But what is implemented? So hardware, this is the hardware ADC. Oh, I've connected to hardware dock. There should be a README. Here's the README. Installation programming keyboard. Here. Some buttons have multiple assigns to them. 110 button is used as a shift button and marked as such in the text below. Okay. Can be selected through the menu. You have to go through a menu. So it has 1 times, 10 times probes. You just have to go to the menu. AC/DC, start, stop, this works. Edge, select edge trigger. I don't know if this works. Trigger mode works. Trigger up, down, this. Does this work? Trigger up, trigger down. Off, on. Let's start again. Okay. It remembers the state. Oh, actually, I think we have the same issue. This is the last screen of the LCD, and the LCD doesn't work anymore. No, it does. Start. Okay, single. How does it work? Trigger, auto trigger. Okay. Trigger up, trigger down. The button work. This works well. What else? Shift, change sample rate limit. Okay, it's shift up, down, vertical position, shift up, down, vertical scale. Okay. Oh, wow. This works quite well. So this is shift. I'll mark it. The 1 times 10 times is actually the shift now to change the mode. And actually now we see the signal. And I have to calibrate the probe. But for now, let's have a look at the signal. That's a shame that when you shift the wave, it doesn't shift the trigger. You have to re-change it. Oh, that works really well. this firmware is awesome. And how do you go to the menu? So we work the scaling, that's shift up, shift down, shift left, shift right. Okay, calibration, shift mode. Your hardware will require calibration. The default calibration values are the values from my development device, so they definitely not work for any device. The calibration, okay. While powering the device, shift plus mode, okay. Fully charged battery, and the charger disconnected. It's better to have the LCD set back. The calibration should be performed on a direction to a device or a probe in one time. In the calibration mode, trigger controls are fixed to auto. Let's try the calibration. I want to see the screen while you're watching it. Let me switch the camera. Let's change the camera. So, new setup. Will this work? We will see. Up, so I'll just put it to the next camera, which is next to my screen. Let's make the focus. No, not manual focus, autofocus. Let's switch the camera. Okay, that works. This way I don't have to change the desk all the time. I can do everything live. So, how do we calibrate this thing? Shift plus mode. Let's read through it before we calibrate it. The calibration should be performed with a direct connection to a device or a probe in one-time sense with the calibration trigger. I'll just read it. I'm just reading the same thing. In the calibration mode, trigger controls are fixed to the auto mode with the rising edge and level set to 0. The trigger control button change their function. Trigger up, trigger down, change calibration value, change calibration parameter. In the calibration mode parameter, the status are replaced with calibration. The default calibration parameter 0, delta between the channel in dual mode channel, while dual mode we only have one. Okay. 0 and delta are common. Well, it works. The device works now. So really, LCD debugging the LCD communication, that's done. Just clean the LCD pads if you have this issue. Because I didn't stream a lot, I will just continue streaming how I calibrate this device and how I use it. But if you're not interested anymore, just stop whenever you want. 0 and delta are common to all vertical scales. Both scale and offset have to be adjusted for each vertical scale individually. Okay. Calibration procedure consists of a few steps. So this was the beginning. The wiki is really well done. Good job. Okay, let's try with the thing. So the first thing is we need to configure 0. Up, up. For that we take the probe. we short the probe or leave it open, but we will short it, which creates actually an antenna. That's fine. So while powering up, we have to press shift, which is 1 times 10 times. I need to relabel it to have something to call it shift. Not ideal, but visible. I have another idea. Let's put some tape on top of it and write on the tape, because it is not 1 time 10 times anymore. It is, so do I have, yes, I do have something like this. Let's get it to the right size. Oh, it's too large. It's both too large and too high. Still too high. That's fine. Just make it straight. Right shift on it and then try to glue it down. Nah, too large. Damn it. I have to cut the next one. This is really damn small. Seems okay. I need a smaller pen. I'm just still able to write on this one. Shifts. I'll also put a note in the case that we flashed with open 5012 that this is the shift button. Not perfect, but does the job for now. Shift. We have a shift button. So the first test is 0. So let's switch it on while pressing shift and mode, I think. Shift and mode. Shift mode switch on. Yes, we're in calibration. We see the raw LEC values right there. These are the raw LEC values, and this is the signal. So we need to put this to 0. Because here this is 0. How do we press enter? Middle of the screen, okay. The middle of the screen represents 0 with raw DC. Okay, the the manual doesn't say where shift, how to go to the next one. Mode? Ah, wait, it did say, I think at the beginning. Change parameter. Ah, up, down, change the trigger value, shift. Ah, trigger up, trigger down. Change the calibration value. It's trigger up, trigger down. Okay, got it. So put the position to 0 volt, trigger up, trigger down, changes the value. So we are now changing the value. And here we are in the middle. Okay, that's changed the first value. Now shift, trigger up, trigger down. Now we're in Z. Oh, we still have some reflection. What if I do this way? Okay, this was Z. Now let's shift, trigger up, D. This is delta. Delta. This test must be performed in dual channel. Sample rate is okay. For this test, input must be shorted. All leads, or at least disconnected. This goal is to adjust the trace so that even in old samples coming from the, that's the two channel, come from the ADC A and B. This is how they make 100 milliseconds. So the two channels have the same value. Okay, can I change something? There's not a lot I can do here. Changing the values does nothing. Delta doesn't work for me. I cannot going trigger up, trigger down. Doesn't do anything. Shift. So this is S, scale. This must be performed in single channel mode. Okay. The vertical offset must be set to 0 volt. This is the case. The input must be connected to the source of the variable voltage. The voltage must be set so the ADC reading are close to the full scale but not clipping. 0 delta row reading can be used to select the appropriate voltage. Ideally, the raw ADC should be in the range DFT0. The exact voltage does not matter as long as it can be measured independently, for example using a multimeter. Okay. So we need to go to the maximum value. So for that I will use up. I will use the voltage, my voltage supply. Let's start with 0 volts. We are in ×1 probe. That should be constant ×1. So let's connect the probe. Tuck. Let's connect and this. Tuck. Now we increase the voltage slowly until we reach Does it do anything? I'm outputting 920 volts now and it doesn't show anything. And I'm on ×1. Is it? Yes, ×1. I'm not. And the output wasn't enabled. Yes, now this works. It should show the ADC values. It doesn't show the ADC values. So this is the maximum. The voltage must be set so that you can close to the full scale. Yes, we are close to the full scale. The voltage, but not clipping. Doesn't look like clipping. Zero delta raw reading must be used to select the appropriate voltage. Ah, zero delta. Okay, ideally the raw DC value should be, okay. So we need to change the zero delta value. That's the thing. The exact value doesn't matter as long as it can be measured independently. We will do that. The calibration must be adjusted until the minimum and maximum values in the status bar match the measured values. That's the position. I cannot change the values again. How do I change the values? Did I miss something? It is closed though. I'm outputting 369 volts, 370 volts, and this is where it measured. Let's use the multimeter for an exact reading. And it says 369. And the oscilloscope shows 371, which is, for me, close enough. The calibration value must be adjusted until the minimum and maximum values in the... Oh, so these are the minimum and maximum 375 and 4 volts. Okay. Match the measured values. How can I change it? Or do I have to change it in shift mode? I don't get it. Is this? I really don't get it. So this is just a vertical position, but we said it should be set to 0. How do I change the calibration value? Normally, let me check again. Trigger up, trigger down, change calibration value. But here if I do trigger up, trigger down, it doesn't change anything. It doesn't change the calibration value at all. Okay, that was the scale. Now offsets. Calibration value for the negative value may be different. It is recommended to perform this procedure for the negative value as well and adjust the calibration until symmetrically results are reached. This step is performed for all calibration scales settings separately. Okay. But I don't know how to do it for one. How should I do it for all? Offset. This will be performed in a single channel. The input must be connected to the source of variable voltage. We have a power supply set variable voltage till it hits the grid plus minus 4 division. 1, 2, 3, 4, yes. Adjust calibration value until the displayed minimum and maximum voltages match the actually measured voltage. Perform this procedure for both positive and negative settings. This must be performed for all vertical settings separately. Let's try if this works. Offset. I can't change the value. I don't know if I'm doing something wrong, but I'm not able to change the values. So I don't know how this time calibration works. This is 0. Oh, the 0 is... Oh, it's changed the value of... What the... okay, no, sorry. We are not in 0 volt now. We are connected. to the offsets. So that must be changed. Yeah, this is 0. This works. I can really shift the values until we're at 0. This looks perfect. This one works. Delta. There's nothing I can do in delta. Shift. There's no value I can change on shift. On shift. Yes, this is scale. I don't know. What's it called? Scale. This is offset. There's nothing I can do in offset. I don't know how the calibration is done. Did I miss something? In the calibration mode, trigger parameter in the status line are replaced with the calibration data. Okay, this is what we see here. That's the calibration data. And it says trigger up and down, change calibration value, but on the offset, it doesn't change anything. This I understand better. We have to do it for every scale. But for now, I can't even change the thing here. In 0 and delta, actually delta also. Let me change shift. That's 0. That's delta. Yes, we set the measurements. In 0 and delta, our screen are split into 2 halves. Yes, on the left ADC, raw ADC readings, and on the right side show the magnified view of the same trace. That's the magnified view. Okay, got it. In the scale, status line show minimum and maximum voltage values. All calibration procedures are performed with constant voltages, so the minimum and maximum voltage should be close. But they will be slightly different due to noise. Yes. How do you show the even and the odd? So this is delta. But whatever I do, I can change. I don't see any change in the values. Now in shift, I can change it. Do I have to change? Let's change the scale. Let's go to 5 volts. No, doesn't do anything. Do I have to read the source code or should I just contact? Here we're in 0. 0 works perfectly. Delta, I can't change anything. Scale, I can't change anything. Offset, I can't change anything. Do I have to validate every time? That's not written. The calibration procedure has a few steps. We Android sample rate. Here we are at offset. Scale sample rate or below? Ah, I have to change the sample rate in delta. Okay, in delta 125, that's the sample rate on the top. We see we are at 125. This step must be performed in dual mode. Sample rate 125, that's what we see here. So in scale, let's go to scale 125. Time overflow. Whoa. Although this is the original firmware. So there's a bug somewhere in the code. Shift mode. That's 0 volts. Maybe if I press shift mode again, it stores the values. This procedure must be performed. Okay. It says nothing how the calibration data is worked. The calibration is entered while powering. Okay. So this is, let's shift to the next mode. It means that the calibration, we're at 0. So put to mode, shift mode to store the calibration. No. Let's switch off and on. We should be at 0. We're at 0 volts. This works at least. No, this doesn't work, because if we enter the calibration mode again, shift mode, enter the calibration mode. Oh, it does work. This works. Shifts. Now the delta. Delta doesn't work. This change doesn't work. Shift. This doesn't work also. I have to contact the author. But the LCD works. We had a time overflow, but this is just probably because of bug in the firmware. I don't know exactly. But the oscilloscope, handheld oscilloscope worked with another efficient, and the issue wasn't in the code. The code was written very well. It was simply in the contact. So that's it actually. I'll close the stream because it works, and I'll have to contact the author to find out how the calibration really works, how to confirm the data, or why we cannot I cannot change the data. Okay, so well, I hope this is unexpected that it was so short, and we don't have to use a logic analyzer, we don't have to use a oscilloscope to debug any signal, but it works. So next time, maybe I have some other devices I will need to debug. Next time will be on YouTube, but I'll make a small announcement, so enjoy.